Everyone, welcome back to our channel. Today in this video we are going to see trigonometry chapter, all the basic formulas which we are going to use in this chapter. Okay, and we are going to do all the exercises of this chapter. Okay, in the upcoming videos I'll be doing all the chapters, so stay tuned. So first go and subscribe our channel so that you will be getting update of all the videos, upcoming videos. Okay, so let's start with the trigonometry chapter. So let's see what is trigonometry first. Okay, so trigonometry is a branch of mathematics which deals with problems related to right angle triangle. Okay, so as you all know, right angle triangle, in a right angle triangle, one of the side will be 90 degrees. Okay, so this is A, this is B, and this is C, and it is right angle at B. Okay, so let's name the sides in the right angle triangle. So the longest side, we have three sides. So one side is called hypotenuse, the other two sides are called as, one is called opposite and one is called adjacent. Okay, so the longest side in the right angle triangle is called hypotenuse. So which is the longest side here? The angle, the side which is opposite to the 90 degrees angle is called hypotenuse. Okay, hypotenuse. Okay, this is the longest side of a right angle triangle and it is opposite to the 90 degrees angle. The other two sides will be depending on the angle, whether the angle is here at the A or whether the angle is at the C. So let's see, I'm naming it. I'll take two cases. This is the first case. So in the first case I'll keep theta. Theta means angle at A. Okay, so theta is an angle. So if the theta is at A, then this will be my opposite side. Okay, the left over side is my adjacent side. Okay, so this is my adjacent side. The angle, the side which is opposite to the angle is my opposite side, and the leftover side is my adjacent side. In the case 2, let's see, I'm drawing the same right angle triangle. Okay, this is A, this is B, and this is C. It is right angle at B. If the theta is at C, okay, so this hypotenuse will not change. Hypotenuse will be same because this is the longest side, and but the opposite and adjacent will change according to the theta. ठीक है, तो अगर theta secant है तो this will be my opposite side and this will be my adjacent side, and adjacent is also known as base. Okay, so now is it clear? If the theta is at A, then the opposite side will be here. If the theta is at C, then the opposite side will be this, and the leftover side is adjacent or base. Okay, so now as you all know, if in the question, in the exercise, they will be giving you two sides. Suppose they are giving, they have given you opposite and hypotenuse, they will say you to find the adjacent side, or else they'll be giving you adjacent side, opposite side, and they will be saying you to find a hypotenuse side. So as you have studied in the lower classes, that if you want to find the any one side of a right angle triangle, then we are going to use Pythagoras theorem. Okay. Okay, so what is Pythagoras theorem? Pythagoras theorem is hypotenuse square, okay, is equals to side square plus side square. Okay, so what is hypotenuse here? So this will be AC square is equals to AB square plus BC square. Okay, if any two sides are given, the third side we can find by using Pythagoras theorem. Okay, next we have trigonometric ratios. Okay, so total we have 6 trigonometric ratios. Okay, first let me draw the right angle triangle. Okay, so this is A, this is B, and this is C, I am keeping theta as A. So this is 90 degrees. That this is opposite side because theta is at A. This is my hypotenuse and this is my adjacent. Okay. So now we have six trigonometric ratios. First is sine theta. The second one is cos theta. The third one is tan theta. And the fourth one is cot theta. And the fifth one is sec theta, or you can call it as secant theta. And the sixth one is cosec theta, or you can call it as cosecant theta. Okay, so first let's see what is sine theta. Okay, the formula of sine theta is opposite by, you can say opposite by hypotenuse. The formula of sine theta is opposite by hypotenuse. The formula of cos theta is adjacent by hypotenuse. So this will be my, according to this triangle, this will be my BC by AC. Okay, because BC is opposite and hypotenuse is AC. Okay, now cos theta is adjacent by hypotenuse, that is AB by AC is my cos theta. Then we have tan theta. Tan theta is opposite by adjacent. Okay, then we have cot theta. Cot theta is adjacent by opposite. Then we have secant theta. What is this secant theta or sec theta? This is hypotenuse by adjacent. Okay, and this is cosec theta is hypotenuse by opposite. Okay, this all are the formulas: sine theta, cos, tan, cot, sec, cosec. More formulas we have. Okay, you can say inverse formulas. These are sine theta. Sine theta also can be written as sine. The inverse of sine theta is 1 by cosecant theta. The inverse of cos theta is 1 by secant theta. The inverse of tan theta is equals to 1 by cot theta. Same as it is, it will repeat. The inverse of cot theta is 1 by tan theta. Okay, then we have the inverse of secant theta. Same, the inverse of secant theta, sine, the inverse of sine theta, the inverse of cos theta is secant theta. So the inverse of secant theta will be also cos theta. So this will be cos theta. Then we have the inverse of cosec theta is our sine theta, because we have here sine theta. Okay, so this all are the basic formulas of trigonometric ratios. Okay, now we will see how to remember this inverse. If you know sine, you should know if sine, if they are saying, then you can say cosec. S means C, C means S, you can remember. Okay, if the inverse of sine will be cosec, the inverse of cos will be sec. If the inverse of sec will be cos, and the inverse of cosec will be sine, and this both will be inverse of each other. So let's derive this formula. And tan theta, we have one more formula here. Tan theta also can be, in terms of sine and cos, it can be written as sine theta by cos theta. Okay, cot theta in terms of sine and cos can be written as cos theta by sine theta. Okay, this much is clear. So you have to remember this all the formulas. If you remember these three formulas, you can get the other formulas also. Okay, so next we have, yes, next we have trigonometric ratios of complementary angles. Sum of the two triangles, that is angle A plus angle B, is equals to 90 degrees. So sum of the two triangles, if they are equal to 90 degrees, these are called as complementary angle. So we have formulas in trigonometric ratios of complementary angles as sine 90 minus theta equals to, we have cos theta. Then we have cos 90 minus theta equals to, we have sine. So remember like this, sine means cos, cos means sine. Then we have other pair, that is tan 90 minus theta equals to cot theta. Cot 90 minus theta is equals to tan theta. Okay, this two will be one pair. Next we have secant 90 minus theta equals to cosec theta. Cosec 90 minus theta is equals to sec or secant theta. Okay, so this will be one pair. Okay, sin 90 minus theta, cos 90 minus theta, sin theta, same as it is. You can remember these are the trigonometric ratios of complementary angles. Next, let's see trigonometric identities. Okay, so we have three trigonometric identities. First is sine square theta plus cos square theta equals to 1. Second identity is secant square theta minus tan square theta equals to 1. Third is cosecant square theta minus cot square theta equals to 1. Okay, so let's see, we can also reframe this trigonometric ratios as this. Okay, so this first trigonometric identity, can be also written as sine square theta equals to 1 minus cos square theta, and again it can be also written as cos square theta is equals to 1 minus sine square theta. Okay, so this identity we can reframe it as secant square theta is equals to 1 plus tan square theta. So the people will get confused if we are writing like this identity. They will think this is a new formula. No, it is, we are deriving this formula from the same identity. Okay, and this also can be written as how secant square theta minus 1 equals to tan square theta. Okay, we are sending this minus tan square theta this side, and plus 1 if you are sending this side, it will become minus. Okay, but this identity we can reframe it as cosecant square theta equals to 1 plus cot square theta. Okay, and this we can write as cosecant square theta equals to minus 1 equals to, you can write it as cot square theta. Okay, so this you can reframe like this also for the identities. We have seen trigonometric identities also, trigonometric ratios, trigonometric complementary functions, formulas also. Okay, in the next video we will be covering exercise 11.1 problem. So stay tuned with me. So like this video and subscribe the channel and hit the bell icon for upcoming videos. So thank you.